of times they actually have a big X-ray machine they wheel in, gamma ray source or an electric X-ray, and they literally take an X-ray film of it and they look just like a doctor would look for any little pockets or anywhere where the metal's an inch thick but only half of it got welded. They'll fail that and they have to cut out the whole section and start over like it never been welded before. So they're very serious about that for anything that the human life and real money rides on. And then most everything is somewhere in the middle. Maybe okay, it's a boat trailer. Maybe the critical parts are like the axles are bolted on. You bought those ready-made, and maybe you have several different places it's welded. Maybe if you're tying two pieces of tubing together, like a box for like for the bed of a boat trailer or something, you might want to put a piece of metal inside it first before you weld them together. So if your weld failed, it would still hold together. And if you do it right, you're beveling the edges. It'll weld to that metal piece as well as the outside pieces. So that you can pretty much guarantee that even if you didn't get it quite right, it's still going to be stronger than that metal would have been before it was welded. And if you're doing something that's not basic mild steel, 1018 or the kind of steels they sell for hot rolled steel, they sell, trainloads of this every week at any kind of steel supplier. It has kind of a mill scale finish. You can get in shapes and tubes and things like that. Anything that's an exotic alloy, like chrome moly, like they make, bike frames out of, or certain stainless steels or whatever, they have data sheets that will tell you exactly how to weld it, or you have to consult an engineer or call the factory and they'll say, oh, this has to be preheated to 350 degrees. You weld it, and then you have to cool it down over, 30 minutes at 10 degrees per minute, until it's cool to room temperature or whatever. Otherwise, it may crack, or we won't guarantee it'll be as strong or whatever. Some of these have different things like that. So it really depends on what you're doing. I mean, most of the stuff we do, you just go overkill. You make sure that the weld you made is as thick as the original metal, and unless there's life riding on it, you don't have to worry too much. If your office chair breaks, well,
That is life-threatening.
That
is life-threatening.
Oh, yeah, chair breaks, that's life-threatening. Especially if you have like a bed of nails, carpet, or something. But yeah, I think everybody should have some kind of weld testing program. If you're gonna build something you're gonna hang on or whatever, you might want to build one and then cut it apart and make sure the welding, slice it in half with a hacksaw or bandsaw. Make sure the weld actually went all the way through, and something like that. Or like I said, you can get a hydraulic jack. You can get a 10-ton hydraulic jack at Harbor Freight for like $50. You can make a little fixture and just crank it up and see what breaks first and how. As long as it took a lot of, if you're really slick, you could put a strain gauge or some kind of load cell on it and measure it in a computer. But for the most part, you just want to see how it fails, and it fails the way you expect. Like it stretches and it bends and it distorts, and then it slowly fails. That's usually better than instantly snapped in two. And sometimes harder, stronger materials will fail less gracefully. Like you can buy grade 8 bolts for your, bolting your car together. They'll take more force than the next grade down, grade 5. But when they fail, they usually shatter in two, as opposed to stretching and pulling apart, which might be desirable because they'll do some warning, stuff like that. But yeah, good question. What we do, like I said, it's common sense and overkill. So we can pull the shape back a little bit and see some other machines. So these are two different kinds of power supplies. This one is a constant current power supply. It's a Miller, it's called a Syncroid 200. It's a TIG welding. And this machine can deliver 200 amps of welding current. And it can give you either the stick welding. We can hook these electrodes up, we'll demo that. Or we can hook up this fancy torch and do what's called TIG welding, tungsten inert gas. TIG welding, you notice we have a gas bottle here. We're basically turning on that gas, we're turning the welder on, adjusting, etc. And this is kind of like using the settling torch, where there's a foot pedal that controls the current. You set how many max amps you're going to use, but then you turn on and off the foot pedal. It starts an arc from this little piece of tungsten. It's been sharpened to a point, and this is actually negative. So the electrons are flowing off of this tungsten and onto your workpiece. Unlike the stick welder, where that's a metal rod that's consumed as you go, this does not get consumed. This is a very high melting point metal that is pretty inert, that will stay out of being melted in your weld. It just provides the heat, this little ceramic cup around it, there's actually, you can see a nozzle, holes in it, where gas flows out. It's argon gas. It provides a nice inert atmosphere for that melting metal to be protected. And so when you, if you do it right, you put the pedal down, and you know, the gas flows, the electricity starts. You'll get a nice little pool of metal that'll literally look like a little pool of mercury. It's that clean and perfect. And then you can use that. You can move that heat around to either join two things by fusion, or you can dip a piece of welding rod in that pool as you go, and you can, you know, build up a little weld bead. And this is very aesthetically nice. You know, these make beautiful welds that are usually X-ray quality without having to do anything special. It's very, you know, can join all kinds of exotic materials, stainless steel, aluminum if you use that on AC. It can join even titanium, all kinds of other difficult to weld stuff. You can also do tricky things like if you have another bottle and a regulator, you can, let's say you're welding some very thin, delicate tubing together, you can purge it with gas so it's shielded on the inside and the outside, and you can make, you know, perfect, you can weld two razor blades together, two soda cans. I can't, but someone's better than I can. Good. I mean, it's amazing. You can weld anything from 1/2-inch steel down to soda cans. It's an amazing process. Disadvantage of it, not very portable. You know, the machine's big. They have inverter ones that are smaller, more like that size, but still not that portable. Require electricity, obviously, and it doesn't work very well outside because that little bit of shielding gas, if there's a breeze, it blows away and your weld just sputters and turns to crap. It also does not work at all on dirty material. You need to grind it, sand it, get it spotlessly clean. A lot of people even clean the rods, everything with acetone before they start, so that there's absolutely no grease, oil, anything. It's something really critical. You know, you might wear gloves and not even get your fingerprints on. But it's a great process for all kinds of things. You know, it'll join just about anything to be welded, and if you get it to stick, chances are it's penetrated and it's good. So it's very controllable. You know, unlike the acetylene torch where you set the flame and that's it, you can raise and lower the foot pedal and get exactly how much heat you want just till you see it burn all the way through or part way or whatever you want to do, and you can control that really well. But yeah, it also is probably the most difficult one to learn. If you start off with the acetylene torch, though, it's the same skill where you're controlling a rod and a torch. And you're holding this about 75 degrees, this about 20 degrees, and you're making a pool, dabbing it, making a pool, dabbing it as you go. But this is a great way, kind of slow, but a great way to weld anything you want to be very aesthetic, nice, as long as it's clean new material. So cool process to see. And this is our last and newest machine. We just got this from Lincoln, won that Red Bull Challenge contest in New York. 300 amp MIG welder machine. So this machine, MIG is metal inert gas, also known as gas metal arc welding. This machine will put out 300 amps of welding current. It can also be used as a stick or a TIG welder. It has ports you can plug those in, so it's kind of versatile. It's all digitally controlled. So this machine has something like 60 different programs for different gases, different types of metal, different thicknesses, etc. And what it does, inside there's a big spool of wire. You can see that? And there's like this roller drive system. And if I pull this trigger, a couple things happen. See this, unlike the TIG gun, which is pretty, it's a pretty skinny cable, this is pretty thick, right? Well, it's flowing gas. It's got kind of a stiff liner for this wire, and it also has the electrical cable in it. So when I pull this trigger, see those drive rollers kick in, and metal comes out. So, and it also energizes this while that's happening. And so as soon as this hits metal plate, this vaporizes. An arc starts. It's a short circuit, and it burns that little bit of wire away. But wire is feeding out, pretty fast, so it happens again and again. I mean, you can crank this up. Basically, the amount of energy going into your weld is pretty much dictated by how fast the wire is going in, how many short circuits per second you get. Now, there are some technical reasons that's not quite accurate. Depending on how fast it's going, it'll go from being a short circuit that goes tap, tap, finite number of short circuits, to being almost a continuous arc, like a spray, where it's just vaporizing as it comes out, or somewhere in the middle, it's like globules, called globular transfer. But yeah, if you have this thing cranked up, it will spool wire out like there's no tomorrow. This would put enough energy. Yeah, this will put enough energy out to probably weld anything from I would say car sheet metal up to maybe 3/4 inch steel in one pass without blinking. And it's 100% duty cycle. This thing can run also on all of our AC welders here. These are both 220. You know, there's a big dryer socket. This is a 50 amp socket. This one can run on 220, single phase, 3-phase. It will also run on 480. It auto switches. It's an inverter power supply, kind of like those newer microwaves. They're a lot lighter. Well, they're doing that in welders too. It isn't just a big transformer. That one's a transformer machine. They're really bulletproof. They're really simple inside. This one is electronic, but it uses less current, and it can adapt to different kinds of power. Like people who do repairs in factories and stuff like these, because they can take it in and plug it into whatever socket they have with the right adapters. You see, it also flows its gas. This is a mixture of argon and CO2, and it shields the weld coat. It's not as critical, the gas on this one. This mixture of the CO2 and argon makes it a little hotter. This one only can use high purity argon. This one can tolerate something a little bit less pure. This one you can have slightly rusty metal, but not really rusty or greasy metal. The stick welder, I mean, it's ideal to clean it, but it'll burn through anything. I think you've seen that, right? You could have 10 years of paint or anything. Yeah, dead animal, it doesn't care. And you can also use it outside, because as it burns that rod down, it's making its own little shielding gas, and that slag is immediately covering it. So there's really not much that can get to it. And that slag is kind of like corrosive, and it does a good job of cleaning all that crap off the metal as it goes. So this is kind of in the middle. This one is really fast. It's a really good, quick way to put down a lot of metal in a short amount of time. This is what's used a lot in production shops. Now, a variation of that is Howard's machine there. That's a flux core arc welder. So you guys can see this metal. I'll pass it around. It's just steel wire, and just solid steel. So this guy right here, these little ones that typically use they're typically going to use flux core wire. You can see that you can adjust the wire speed on this one. It has 2 heat ranges.
John's giving his class now.
And it's the same kind of thing. It's got a wire feeder, but it takes a smaller spool.
Hi.
And you see there's no hookup for a bottle. Well, this wire actually has, it says inner shield. It's got a core just like rosin core solder.
Oh. Yeah, I'll ask him. He's giving his welding class right now.
It basically makes a shielding gas and a little bit of slag. Now, it's actually not legal to use
okay, sounds good.
MIG welding outside for like structural fabrication in most places by code and whatnot.
Sounds
because
good.
if wind comes up, it could blow away the shielding gas and make a poor quality weld, and you might not know it. Whereas if you use the shielding gas, you use that flux core wire, there's always enough of that flux burning to keep it shielded and safe. So you can hook that up. They usually get a little bit more penetration also, and they don't, but they require more cleanup. They leave spatter and junk behind. So, this one does, Now we can also run the flux core wire in the big machine. There might be certain stuff you want to weld with that. You can even use both. You can use the gas and the flux core. We call it dual shield. And that gives you the best of both worlds. It gives you a better shielding because you have the gas, but if for some reason the gas got blown away, or you're welding with dirty metal, that flux will take care of that. So, and this is finally just a little portable assembly.
The only electric welder I could find that was reasonably bright and was run on a 110 home socket.
Yeah, on a house socket. These do a surprisingly good job, especially if you have a good 20 amp socket to plug it into. They'll work on a regular socket, but if you have a socket that nothing else is on, that has 12 gauge wire going to it and everything, and you get it dialed in, they actually work pretty well. And it looks like you got some Lincoln brand wire. You got to use good wiring too. Like, don't buy crap materials, even if it's a cheap unit. Okay, perfect. No, that will do the job. I mean, we used a little portable welder like that on a cave gate we built. We had to hike everything 2 miles back, and the only generator that was carryable was this 40-pound little Honda. 2,000 watt generator, and it would run that welder. And we were able to weld. We made a quarter-inch thick 4-inch angle iron, pretty heavy steel. But if you go slow and you attack the corners, and let it cool down, and go slow, you get enough penetration. We laid a lot of weld bead to make sure it held, but it worked. You can do stuff if you have the patience to do multiple passes and whatnot. Run over it again.
So you guys made CHC anchor it into the rocks?
Yeah, we did. We brought a big hammer drill. We drilled 1-inch pins into the walls. We hammered the pins in. We put the gate up. We welded all the pieces up. We had these 2 columns made out of angle iron in 3 pieces. So one upright piece got tacked on, and then 2 pieces to make it into a box. And it had little shelves made of angle iron, and the angle irons went on top of that.
Is this just for general caving, or is this interesting?
That was Desert Dogs, their cave club that meets here. So we did that as like this land conservancy wanted to turn it over to the Forest Service, but they wouldn't take it because it had a mine on it, and they wanted to blast it shut. And the cavers didn't want to blast it shut. I said, okay, well you can build a gate on it. So we helped them build a gate. We ordered 1,000 pounds of cement in 10-pound bags, and we got a Boy Scout troop to hike all that stuff up there. Yeah. And the steel pieces, we tried to keep them like 40 or 50 pounds and weld them together when we got them there.
Give them all patches.
Yeah, I think they got their, we brutalized those kids. That was great. Yeah, totally worked.
Yeah, energetic young man. Yeah.
Now, cooling, they make, like Lincoln and Miller, and there's another company too, they make inverter-based little portal welders like this. They can actually like stick weld with even heavy-duty materials off of a 110 outlet. Because they're really efficient, they can burn like 332nd, like 7018 rod or 6011. And I saw a video of somebody had fixed a bulldozer blade with a 110 arc welder. But it was that one's like $1,500. I mean, it's all like super high-end SCRs and stuff.
I couldn't find anything that was reasonably priced.
Yeah, no, they're not cheap. The people who use them for doing like restaurant repairs, because they have, some of them have TIG welders built in, like where they have stainless sinks and fixtures and all that.
Some of them have plasma cutters built in.
Some of them have plasma cutter, yeah. So like you can fix the stuff in a hospital or a commercial kitchen or something. They want to add 2 new shelves and lengthen this counter and put a new counter in where the dishwasher used to be or whatever. They can do all that. Just take this little suitcase out, plug it into the outlet, works great. But those are all high dollar. I mean, those are $1,000 and up. For comparison, yeah, these are what $200 or $300?
$108 if you want.
Can't beat that. You can get a submarine cutting rig for about $300. You can rent the tanks. I was lucky enough to search around the swap meet and find a good set of tanks used, which basically have trade-in value. If you're not going through them all the time, they charge you about $5 to $10 a month per tank per month. So after a year, if you can find a set for $150, it makes sense to just buy them. That TIG welder is about a $2,000 machine. This one, I don't even want to know what it costs if I had to buy it. It's probably like a $4,000 machine. But you can get something that will, depending on what you're trying to do, I mean, starting at literally $200 or $300. An AC buzz box, stick welder, or a settling rig, $200 to $300 price range. You get going into a lot of projects. So you guys have any questions on that? Ready to take a little break and get some water or whatever, and we'll do some welding?